Hello students, welcome to T.I.M.E online classes. Today we are going to deal with a new topic, that is differential equations. This is also a very important topic as far as JEE and any other entrance exam is concerned. So let's start with the chapter. In this video, I'm just going to explain the three different methods of solving differential equation. So let's start one by one. So the first type of differential equation or the solution, how to find out the solution of the differential equation, is variable separable method. Whenever your differential equation is of the form dy by dx equal to f of xy, and if you can split this differential equation as f of x dx equal to g of y dy, then g of y dy, then just by integrating both sides and adding the constants to any one of the sides, we can find the solution of the differential equation. And this method is called variable separable. So variable separable. So if you can separate the variables, then in that case we call it variable separable. Second type of equation is homogeneous differential equation. So whenever you can write a differential equation in the homogeneous form means a function is said to be homogeneous if f of xy is equal to y raised to n into f of x by y. So if you can write f of xy as a function like this, y raised to n into f of x by y, then the function is said to be homogeneous. Whenever a function is homogeneous, we can differentiate, that is, whenever f of xy is homogeneous, we can differentiate the given function, or we can find the solution of the differential equation by just replacing y equal to vx and dy by dx is equal to v plus x dv by dx. Once we do this, our differential equation will become variable separable and then solve it. So this is the second type of equation that we are going to deal with. This is homogeneous differential equation. And the third case is linear differential equation. So linear differential equation, we have the differential equation is of the form dy by dx plus py equal to q, where p and q are functions of x only. In that case, first we'll find out the integrating factor, which is written as if equal to e raised to integral p dx, and the solution is given by y into e raised to integral p dx equal to integral of q into e raised to integral p dx. Now integrating this will get the required answer. So in this session, I'm just going to explain a few problems based on these three methods, that is variable separable, homogeneous and linear differential equations. I hope you are ready. So let's start with the first question. Our first question is, let y is equal to y of x be the solution of the differential equation x cube dy plus xy minus 1 into dx equal to 0, x is greater than 0, and we are given that y of half is equal to 3 minus e. We have to find out the value of y of 1. So let's first try to rewrite this equation like this: x cube dy equal to, when you take this term to the right hand side, it will become negative. So I'm going to write it as 1 minus xy into dx. Now just by looking at this, we are sure that this is not variable separable and neither homogeneous. So I'm just going to convert it into form linear differential equation. So let me write x cube dy by dx equal to 1 minus xy. Let's divide by x cube. So we have dy by dx equal to 1 by x cube minus xy by x cube. That means y by x square. 1x gets cancelled and you'll get y by x square. Now let us rearrange and we'll get dy by dx equal dy by dx plus y by x square equal to 1 by x cube. Now, when you compare, instead of p, your form is dy by dx plus py equal to q, where p and q are functions of x only. Now, comparing with this, we have p is equal to 1 by x square. So, integrating factor is e raised to integral 1 by x square. So, what do we get? E raised to integral 1 by x square dx. So, we have e raised to minus 1 by x. This will be the required integrating factor. So, what is the solution? You'll find the solution like this: y into integrating factor, that is y into minus 1 by x equal to integral of e raised to minus 1 by x into, what is the right hand side? Right hand side is 1 by x cube, 1 by x cube dx. So, this is what we have to integrate. So, now I'm just going to take u is equal to minus 1 by x. If u is equal to minus 1 by x, du by dx is 1 by x square. So that you have du equal to 1 by x square dx. And also we have one more 1 by x here. So the equation will become, the right hand side will become, let's write the full equation: y into e raised to minus 1 by x equal to integral of e raised to minus 1 by x. That means it will be e raised to u into 1 by x cube. I am going to write it as 1 by x into 1 by x square. But what is 1 by x? 1 by x is minus u, and 1 by x square dx is written as du. So you have minus u into e raised to u du. So this is integration by parts we have to apply here. So let's write y into e raised to minus 1 by x equal to minus of. Here u is an algebraic function and e is an exponential function. So when you apply I late, u is the first function and e raised to u is the second function. So u into integral of u e raised to u minus integral of derivative of u into e raised to u du. So this will be the required integral. So we have, and plus c. So we have y e raised to minus 1 by x equal to minus u e raised to u plus e raised to u plus c. So now what is u? U is negative 1 by x. So we have y into e raised to minus 1 by x equal to minus of minus 1 by x. So we have 1 by x into e raised to minus 1 by x plus e raised to minus 1 by x plus c. So let's divide the whole equation by e raised to minus 1 by x. So we have y is equal to 1 by x plus 1 plus c e raised to 1 by x. Now we are given that y of half is 3 minus c. So instead of x, if we put half, we'll get 3 minus c. So let's write 3 minus e equal to 1 by 2, which is 2 plus 1 plus c e square, because 1 by 2 is 2. So now what happens? This 3 and 2 plus 1, 3 cancels. So we have minus e equal to c into e square, or let us write c is equal to minus 1 by e. So we get y equal to 1 by x plus 1 and minus e raised to 1 by x minus 1. So this is the required expression. Now in this, we have to put x is equal to 1. When you put x is equal to 1, we get y is equal to 1 plus 1 minus e raised to 0. What is e raised to 0? E raised to 0 is 1. So we have 2 minus 1 is 1. So the required answer is option 3. I hope it's clear. Now let's work out our next question. Our next question is, let y is equal to y of x be the solution of the differential equation x square minus 3y square dx is equal to plus 3xy dy equal to 0. So just by looking at it, we can be sure that it's a homogeneous equation. Look at the coefficient, look at the powers of the variables. It is all 2. So we can be sure that it's a homogeneous differential equation. So I'm just going to rewrite this. So we have 3xy dy equal to, when it goes to the right hand side it will become negative, so I'm just going to adjust the negative and we can write it as 3y square minus x square into dx. So that dx I'm going to write here. So now we have dy by dx is equal to 3y square minus x square whole divided by 3xy, or we have, when you replace y by vx, we get y equal to vx and dy by dx is equal to v plus x dv by dx. So what do we get? V plus x dv by dx equal to 3v square x square minus x square whole divided by 3x into vx. So x square cancel from each and every term. So we'll get 3v square minus 1 by 3v is v plus x dv by dx. Let's take v to the right hand side. So we have x dv by dx is equal to 3v square minus 1 divided by 3v minus v, or we have 3v square minus 1 minus 3v square by 3v. This is the expression. So 3v cancels. So now we have 3v dv equal to minus dx by x. So instead, let me keep this 3 on the right hand side itself. So that will get v dv equal to, let me just correct it. So that will get 3 v dv is equal to minus 1 by x dx. Now integrating both sides, we get v square by 2 equal to minus 1 by 3 log x plus log c. You can either write c or log c. Now let's replace v by y by x. So we get y square by 2x square equal to minus 1 by 3 log x plus log c. Now we have to find out what is log c. For that we are given y of 1 is equal to 1. What does this mean? When x is equal to 1, y is also equal to 1. So let's write 1 by 2 into 1 equal to minus 1 by 3 log 1 plus log c. Now log 1 is already 0. So we have log c equal to half. So that your equation becomes y square by 2x square equal to minus 1 by 3 log x plus half. Now we have to find out 6 into y square e. For this, I'm just going to replace x by e. When you put x is equal to e, we get y square by 2e square equal to minus 1 by 3 log e plus 1 by 2. Now what is log e? Log e is 1. So we have minus 1 by 3 plus 1 by 2. So we get minus 2 plus 3, that is 1 by 6. So y square is 2e square by 6, or we can write e square by 3. Now what do we have to find out? We have to find out 6 into y square, right? So 6 into y square, at E is given by 6 into E square by 3. So cancelling common factors, we have 2E square. So the required answer is option 4. I hope it's clear. Our next question is, let y is equal to y of t be a solution of the differential equation dy by dx plus alpha y equal to gamma into e raised to minus beta t, where alpha greater than 0, beta greater than 0, gamma greater than 0. Then we have to find out limit t tends to infinity y of t. So looking at this equation, we are sure that this is a linear differential equation. So we have to solve it. Let's try to solve it. So here we have dy by dt plus alpha y equal to gamma e raised to minus beta t. So instead of p we have alpha. So integrating factor is e raised to integral alpha dt. So we have e raised to alpha t. This is the integrating factor. Now how will you write the solution? Y into e raised to alpha t equal to integral of e raised to alpha t into gamma into e raised to minus beta t dt. Here gamma is a constant, so let's take it outside. So we have y into e raised to alpha t is equal to gamma into integral e raised to alpha minus beta into t dt. A raised to m into a raised to n is a raised to m plus n. So that is what we have to answer. Now let's integrate. So what do we get? Y e raised to alpha t equal to gamma into e raised to nx. What is the integral? E raised to nx by n. So e raised to alpha minus beta t by alpha minus beta plus c. Now let's divide the whole equation by e raised to alpha t. So we get y is equal to gamma into e raised to minus beta t divided by alpha minus beta plus c into e raised to minus alpha t. Now we are given that we have to find out limit t tends to infinity y of t. So already we got y of t. Now we have to somehow find the value of y of t as t tends to infinity. As t tends to infinity, e raised to minus alpha t as well as e raised to minus beta t will become 0. Why? Because e raised to minus infinity is 0. So what do we get? Y as limit t tends to infinity, y of t will be equal to, this term will become 0, this also will become 0. So gamma by alpha minus beta into 0 plus c into 0. So the final answer will be equal to 0. So the required answer is option 2. So answer is 0. I hope it's okay. So let's work out the next question. The question is, let y is equal to f of x be the solution of the differential equation y into x plus 1 dx minus x square y dy equal to 0. So y of 1 is given to be equal to e, and we have to find out limit x tends to 0 plus. That means the right hand limit as x tends to 0 f of x. So this is what we have to find out. So let's just rearrange this. So we have y into x plus 1 dx equal to x square into dy. So looking at this, it's clear that this is a variable separable equation. So let's take all the x terms to the left hand side and all the y terms to the right hand side. So what do we get? X plus 1 by x square dx equal to dy by y. That is 1 by x plus 1 by x square dx equal to dy by y. Let's integrate both sides. So what is integral of 1 by x? Log x. And integral of 1 by x square? Minus 1 by x. And the right hand side is log y plus log c. Now we are given that y of 1 is equal to e. That means when you put x is equal to 1, y is equal to e. So let's put x is equal to 1. Log 1 minus 1 by 1 equal to log e plus c. Now what is log 1? 0 minus 1 equal to log e, again 1 plus c. So from this we can say c is equal to minus 2. So that we can write the equation as, so instead of c it will be actually log c, which is again a constant. Okay, so log c is equal to negative 2. So that your equation becomes log x minus 1 by x equal to log y minus 2. Let's rearrange. So log y equal to, I'm taking the negative to the left hand side. So we get log y is equal to log x minus 1 by x plus 2. Now just to make this as y, let's take e to the power on both sides. E raised to log will get cancelled and we'll get y is equal to e raised to this whole expression, that is log x minus 1 by x plus 2. Or let us write e raised to log x into e raised to minus 1 by x into e square. This is y. E raised to log x, e raised to log get cancelled and we'll get y is equal to x into e raised to minus 1 by x into e square. Now we need limit x tends to 0 plus, that is right hand limit as x tends to 0. But here we have a x quantity, so we can say that the limit will be equal to 0. So limit x tends to 0 plus f of x will be equal to 0. So the required answer is option 3. I hope it's clear. Now let's work out the next question. The slope of the tangent at any point xy on a curve y is equal to y of x is x square plus y square by 2xy, where x is greater than 0. Also we are given that y of 2 equal to 0 and we have to find the value of y of 8. So slope of the tangent, please note slope of the tangent will be dy by dx and slope of the normal will be minus dx by dy. So if you don't know this, please note that the slope of the tangent is dy by dx. Given that dy by dx is equal to x square plus y square divided by 2xy. So obviously this is a homogeneous differential equation. So we'll replace y by dx and dy by dx by x plus v plus x dv by dx. So we have v plus x dv by dx equal to x square plus v square x square divided by 2x into vx. X square cancels from each and every term, so we get 1 plus v square by 2v. Now let's take the v to the right hand side. So we have x dv by dx equal to 1 plus v square by 2v minus v. So we have 1 plus v square minus 2v square divided by 2v. So rearranging this is actually 1 minus v square by 2v. So let's rearrange. So we get 2v by 1 minus v square dv equal to dx by x. Now we have to integrate both sides. When you integrate 1 minus v square, the derivative of 1 minus v square is minus 2v dv. So let's write minus log 1 minus v square equal to log x plus log c. So this is what we are getting. Minus log 1 minus v square is equal to log x plus log c. Or let us write log 1 minus v square the whole raised to minus 1 is log cx. Why? Because log a plus log b is log ab. That is log, cancelling log on both sides, we have 1 by 1 minus v square equal to cx. Replacing v by y square by x square, we have x square by y square minus x square equal to cx. Let's cancel out 1x so that we'll get x equal to c into y square minus x square. Now we are given that y of 2 is 0. So let's put x is equal to 2 and y is equal to 0. So 2 is equal to c into 0 minus 4. So we have c is equal to minus 1 by 2 because 2 by 4 is 1 by 2. So minus 1 by 2. So we have x by y square minus x square is minus 1 by 2. So this is what we are getting. Now we want y of 8. When x is equal to 8, we want what is y is equal to. So let's rearrange. So 2 into 8 equal to minus of y square minus x square, or let us write x square minus y square. What is x square? 64 minus y square. So we have y square is equal to 64 minus 16, which is equal to 48. So what is y? Y will be root 48, which is equal to plus or minus 4 root 3. Now we don't have the option minus 4 root 3. So the answer is option 2, 4 root 3. I hope it's clear. Now our next question is, if the solution curve f of xy equal to 0 of the differential equation 1 plus log x to the base e dx by dy minus x into log x to the base e equal to e raised to y, x greater than 0 passes through the point 1 0 and alpha 2, then alpha raised to alpha is equal to. So for this, just by looking at this, this is not variable separable, nor homogeneous. It's not even in the form of differential, linear differential equation. So what I'm going to do is, let's put x e raised to x as u, x log x as u. So let's put u is equal to x into log x to the base e. So du by dy, let's find out what is du by dy. Du by dy is x into 1 by x into dx by dy plus log x to the base e into dx by dy. So I have used product rule on the right hand side. So when you take x cancelled and when you take dx by dy as a common factor, you will get 1 plus log x to the base e dx by dy is du by dy. So that now your integral is of the form du by dy minus u equal to e raised to y. So now this is of the form dy by dx plus py is equal to q. So let's find out integrating factor. So integrating factor is e raised to integral minus 1 dy. So we have e raised to minus y. This is the integrating factor. So how will you write the solution? Y into, usually we write y into, here the variable that we have is u. So let's write u into e raised to minus y equal to integral of e raised to minus y into e raised to y dy. So we have u into e raised to minus y equal to integral 1 dy. What is integral 1 dy? It's y. So u into e raised to minus y equal to y plus c. Let's just replace what is u. U is x into log x to the base e. So we have x into log x to the base e raised to minus y equal to y plus c. Now given that this equation passes through 1 0, So when you put x is equal to 1 and y equal to 0, what do we get? 1 log x 1 to the base e into e raised to 0 equal to 0 plus c. So obviously c is 0. So we have x log x to the base e raised to minus y equal to y. So take y to the right hand side, e raised to y to the right hand side. So 1 y by e raised to minus y will become y e raised to y. So we have x log x to the base e equal to y e raised to y. Now what do we want? We are given that alpha, when you put alpha, we'll get 2. So alpha log alpha to the base e, alpha to the base e is 2 e raised to 2. So let's rewrite it as n log a is log a raised to n. Log alpha raised to alpha to the base e is 2 e square. Now to get rid of log, let's exponent, or let us power both sides with respect to e. Take e to the power on both sides. So we have e to the power log will get cancelled. So we'll get alpha raised to alpha equal to e raised to 2 alpha square. So the required answer is e raised to 2 alpha square, which is option 1. I hope it's clear. Now, our next question. Let y is equal to y of x be a solution curve of the differential equation 1 minus x square y square dx is equal to y into dx plus x into dy. This is a peculiar type of equation, that's why I have selected this. So 1 minus x square y square into dx is equal to, look at this, y into derivative of x plus x into derivative of y. So which is nothing but differential of xy, right? So let's rearrange, we'll get like this, dx is equal to differential of xy divided by 1 minus x square y square. Now integrating both sides, what do we get? Here the integral is x, and on the right hand side 1 by a square minus x square. The integral of 1 by a square minus x square is 1 by 2a log a plus x by a minus x. So let's write 1 by 2 into a. A is 1 log 1 plus x by 1 minus x. So 1 plus xy divided by 1 minus xy plus c. Now we are given that if the line x is equal to intersects the curve y is equal to y of x at y is equal to 2. So the point at which this meets y of x, x is equal to 1 meets is y is equal to 2. So that means you have to replace x by 1 and y by 2. So what do we get? 1 is equal to 1 by 2 log, what do we get? 1 plus 1 into 2, that is 2, divided by 1 minus 2 plus c. Now 3 by negative 1, which is negative 3. Modulus of negative 3 is positive 3. So this is log 3. So we have c is equal to 1 minus 1 by 2 log 3. Now our equation becomes x is equal to 1 by 2 log 1 plus xy by 1 minus xy plus 1 minus 1 by 2 log 3. Now we have to find out the value of alpha. If x is equal to 2, y it will intersect at y is equal to alpha. So let's put x is equal to 2 and y is equal to alpha. So 2 is equal to 1 by 2 log 1 plus 2 alpha divided by 1 minus 2 alpha plus 1 minus 1 by 2 log 3. So here what happens is you will get When you multiply by 2, you have 4 equal to log A minus log B. So let's write 1 plus 2 alpha by 1 minus 2 alpha into 3 in the denominator plus 2. That is 2 is equal to log 1 plus 2 alpha by 3 into 1 minus 2 alpha. So taking e to the power on both sides, e square is equal to 1 plus 2 alpha by 3 into 1 minus 2 alpha. Remember, since it is modulus, it can be plus or minus. Okay, plus or minus e square. So let's take the negative part, because when we try with e square, 3e square, we won't get the options. So let's try with minus 3e square. So I'm taking the negative part here. So instead of here you have a modulus, so I'm taking the negative part, and that's why I have a negative here. So minus 3e square is equal to 1 plus 2 alpha by 1 minus 2 alpha. Let's cross multiply. So we have minus 3e square minus of minus. So plus 3e square into 2 alpha equal to 1 plus 2 alpha. So 2 alpha into 3e square, 3e square minus 1 equal to 3e square plus 1. So we have alpha is equal to 3e square plus 1 divided by 2 into 3e square minus 1. So the required answer will be option 1. I hope it's clear. Now our next question is, let y is equal to y of x be a solution curve of the differential equation 1 plus x square into dy equal to y into x minus y dx. If y of 0 is equal to 1, we have to find out y of beta such that y of 2 root 2 equal to beta. So let's do one thing. Let's first rearrange. So 1 plus x square, let's write 1 plus x square into dy equal to y into x minus y into dx. I'm writing the dx here. Let's take 1 plus x square on the right hand side. So we'll get dy by dx equal to xy by 1 plus x square minus y square by 1 plus x square. So this is not in the form of linear differential equation. So we have to convert it into linear differential equation form. So let's do one thing. Let's first divide the whole equation by y square and rearrange. So we have 1 by y square dy by dx minus x by y into 1 plus x square equal to minus 1 by 1 plus x square. So I have divided the whole equation by y square. So let's take 1 by y as t. So that I'm trying to convert this into linear differential form. So let's take t is equal to 1 by y. So dt by dx will be minus 1 by y square dy by dx. So if you take this as negative, here it will be plus. So that will be a bit more easier. So let's take negative 1 by y, and here it will be plus 1 by y square dy by dx. So what do we get? dt by dx plus x by 1 plus x square into t equal to minus 1 by 1 plus x square. Now look at this, x by 1 plus x square and minus 1 by 1 plus x square are functions of x only. So definitely this is of the form linear differential equation. So let's find out the integrating factor. What is the integrating factor? e raised to integral x by 1 plus x square dx. So here we have e raised to half log 1 plus x square. So that is e raised to log root 1 plus x square. E raised to log cancels and the integrating factor is 1 plus x square. Solution is given by t into root of 1 plus x square is equal to integral of root of 1 plus x square into minus 1 by 1 plus x square dx. So root of 1 plus x square cancels and we get t root 1 plus x square equal to integral of minus 1 by root of 1 plus x square dx. So now what is t? T is minus 1 by y. So minus root of 1 plus x square by y equal to minus log x plus root of 1 plus x square plus c. Now let's put x is equal to 0 and y is equal to 1. So we get minus 1 equal to minus log, how do we get minus 1? 1 plus 0 square, that is 1, and this is also 1. So minus 1 equal to log x is 0, 0 plus root of 1, that means log 1 plus c. So here log 1 is 0, so therefore c is minus 1. So all negatives will become positive and we'll get the expression like this, root of 1 plus x square equal to log x plus root of 1 plus x square plus c. C is minus 1. So minus of minus 1 will become plus 1. Now let us put x is equal to 2 root 2. So what do we get? 2 root 2 square, that is 8. 8 plus 1, 9. 9 by root of 9 is 3. 3 by beta equal to log, what is x? X is 2 root 2, 2 root 2 plus 3 plus 1. Now what is 1? 1, let us write it as log e. Log a plus log b is log ab. So let's write 3 by beta equal to e log e into 3 plus 2 root 2. So taking e to the power on both sides, what we get is e raised to 3 beta raised to minus 1 equal to e raised to 3 beta raised to minus 1 equal to e into 3 plus 2 root 2. So the required answer is option 4. I hope it's clear. So we have covered all the methods of solving differential equation in this session. I hope you enjoyed the session. Hope to see you soon. Thank you.